Okay, so we talked yesterday about the application of the fundamental theorem of calculus, where we're looking for like the final value, that's the initial plus the change, right? So this rate in, rate out stuff, this is a very, very common way to use all of this put together. Okay, so instead of water just leaking out of something or just pouring into something, both things are going to be happening. Like if you try and plug up my kitchen sink, most of the time the little plug thing doesn't work, but you don't realize it till it's too late. But it leaks out slower than what I'm pouring in, so I don't know it first, and then it just keeps leaking out, right? So there's water coming in, water going out, that type of thing. So these problems are contextual, real-world applications. So big idea number one, integrating a rate. Integrating a rate gives you a total change. That's what we're looking for, right? Big idea number two, finding a final value of a function requires integration when a rate or a derivative is given. So your final value is your given or your starting value plus your total amount added minus the total amount lost, right? So when we look here, so in calculus terms, your final amount is the initial plus the integral of the rate in minus the integral of the rate out. And so that's what this looks like. Right here, your A of t, that's your total or your final, and then your initial, and then the two rates. Okay? So this is critical. This is very, very important. Most AP problems start by giving a rate equation. Then they will ask you to find an amount at a given time. To do this, we will use the above formula in many, many different ways. So you have to read what you're given and think about what is what and maybe label some things so that you can use it along the way correctly. So when given a rate, f prime of t, and asked to find a value, f of c, we will use the above formula in some way. All right. So let's look at this. We have first example here. All right, so at 9 a.m., which is t equals 0, it's important to know, Indianapolis Metropolitan Airport has 1,350 people in it. That means your initial amount, your A of 0, is equal to 1,350. For t being between 0 and 12 hours, people are entering the airport at a rate of E of t. So E of t, that is your rate in, because they are entering. During the same time interval, that's important to pay attention to, what our time intervals look like. People leave the airport at a rate of L of t. So L of t is your rate out. E of t and L of t are both measured in people per hour. How many people enter the airport? How many people enter the airport between 12 p.m. and 5 p.m.? So if all we're asked is how many people enter the airport, we're only using the rate in, that is people per hour. If I want the amount of people, what do? If I want to go from the rate, which is people per hour, to people, I have to integrate. So I'm going to integrate the E of t, because that's the people entering. And it says from 12 p.m. to 5 p.m. So especially when it gives us time, we've got to pay attention to, it says at 9 a.m., t equals 0, 3 to 5. So this is t equals 3, and this is t equals, not 5, 8. I was like, yes, but it's 8. So I'm integrating from 3 to 8. Everybody okay with all that? That makes sense? Understand where I came up with all the numbers? Okay. If I want to know how many people are in the airport at 4 p.m., that is my total amount, right? So that's A of t, whatever t happens to be here. What's my initial amount? 1,350. My initial amount, A of 0, that is 1,350, right? Then I'm going to add to that the number of people that have entered, so that's an integral. So at 4 p.m., that would be t equals what? 7. I always count on my fingers for time. I'm at 9, so that's 10, 11, 12, 1, 2, 3, 4, right? 7, t equals 7, so I don't mess it up. So from 0 to 7 of e of t dt, then what do I have to do? Subtract people leaving. And they're leaving from 0 to 7 also, L of t dt. Initial amount plus whatever got added minus whatever left. Everybody good with that? All right, so now it says, write an equation involving one or more integrals that gives the amount of people inside the airport at any time t for 0 to 12 hours. So I'm looking for a of t. That's equal to 1350. I'm still going to have to add the integral of how many people entered, right? And then subtract the integral to find how many people left, right? I'm still going to start at 0, and I'm going to go to any time t, right? T is my any time. So right here, can I write e of t dt? It is the e function, but can I use t? I have to use x or any other variable besides t, really, but x makes the most sense. E of x dx minus the integral from 0 to t of L of x dx. Okay, we good with that? So when we go to any time t, we have to make sure we use the dummy variables there. Okay, we okay with that? What questions you got? Okay, good deal. So let's read this next one. On Monday morning, from 0 to 8 hours, Mr. Passwater receives emails in his inbox at a rate of I of t emails per hour. So I of t is your rate in. Okay. During the same time, and that whole same time is important, he is deleting emails in his inbox at a rate of d of t, and that's your rate out. Okay. At time t equals 1, he has 159 emails in his inbox. So a of 1 is 159. Okay. We're good with that? All right, so on A, it says, how many emails are deleted from his inbox from t equals 0 to t equals 7 hours? So if we figure that out, does our initial amount matter? No. Does the rate in matter? No. All we're looking for is deleted, right? So I need the integral of what? D of t, yeah. Okay, no, I know I said that weird. Of d, integral of d of t dt, which is weird because of the d's and the t's, right? And my limits of integration, I'm going from 0 to 7. We all good with that? Okay. So then it says how many emails are in his inbox at time t equals 8. So I want a of 8, right? What is the initial amount we have? 159, okay? So to that we're going to add, yes, go ahead. It still works with 159 because of what we're about to do right here. So good question. We're not going from 0 to, here it told us to go from 0 to 7, and we can know how many got deleted, right? Here it says at time t equals 8. Well, I don't know when t equals 0, I don't know what it is. But I do know when this is when t equals 1, right? T equals 1, I have 159. So that means I'm going to take this 159 and I'm going to integrate from 1 to 8. Exactly. Does that make sense? Because yeah, between 0 and 1, something happened, but that was our result, That 159 was our result of whatever happened. So then we just start from there and keep going. Okay, does that make sense? It's a very good question. And this is going to be our I of t dt. And make sure you don't leave off the dt stuff when you write your integrals. Okay. And then we're going to subtract the integral. What are our limits of integration here? 1 to 8 of d of t dt. Okay. What questions you got? All right. So now I want you to see if you can write this. Write an equation involving one or more integrals that gives the amount of emails in Mr. Passwater's inbox at any time t. Why do you have 12? Because that's from 0 to 12. That's not at any time. That'll give you over the whole 12 hours. No, don't pick a time. You don't get to pick a time. It's any time t. So write an equation for any of it from 0 to 12. So is it going to look very similar to what was in B? Right? We only know one initial amount. We know this 159, right? And to that I'm going to add what's entering, but I don't get to start at 0 because I don't know what t equals 0 is. Whatever happened between 0 and 1 hour has already happened, and this is our result, right? So we're starting at 1. And then I'm going to go to any time t. I don't know what it is. I know t is going to be between 0 and 12, but it's going to be any time t, right? Does that make sense to you so far? So then when I do I can't do I of t, but I can do I of x dx. Then I'm going to subtract the integral. I have to start at 1, and I'm going to go to any time t, and then it has to be d of x dx. Okay? What questions do you have? Anything? Okay. So then on example 3, I'm going to give you a few minutes. I don't want you to actually type anything into your calculator yet. I just want you to write out what's your rate in, your rate out, the stuff that we've written, and see if you can set these 3 up. Okay? Talk to each other. Get them set up. Let me give you a few minutes for that on your own. Okay, so that looks real good, but let me ask you, when do people start leaving?
I have a question.
Mm-hmm.
So I understand what you're saying. So whenever I write the integral,
Mm-hmm.
do I write, is this, or that's at 2, right?
It starts at 2, yes.
Do I have to put 2, or does that start at 1 and then 2?
Okay, well, so here, t equals 0 is noon, right? It's 12 p.m. So t equals 1 is going to be 1 p.m. T equals 2 is going to be 2 p.m. Does that make sense? I always count on my fingers so I can get that right. So this is t equals 2 right there. Does that answer your question? Okay. No, that's fine.
I know it's at 2, right?
Mm-hmm.
We put 2 at the bottom of our starting.
Yes, because we're starting at 2. Which, tell me why on the first integral you have 1 at the bottom.
Why? Because they don't.
Okay. But you understand why you have 2 at the next one?
Because at t equals 0, we're given that we have already.
Right. So when I start, time has not even started yet. I have 412 people in there. So then they hit start. And I go through 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes, 6, all the way to 60 minutes. Then boom, after 60 minutes, I'm at 1 hour. So I've actually started adding people at time equals 0. I started adding people at noon. Because at noon, there's already 412 people in there. That's when the clock starts. When time is 0, think about a graph. You start at 0, and you start adding people before you ever get to 1. So that should be 0. Does that make sense? And so do you understand why it's like that then? Well, I'll talk through it too, but okay, good. All right, so let's see. We're looking at how many people enter the stadium during the first 3 hours. So when it says first 3 hours, the actual time of day doesn't even matter, right? So we are looking for the integral from 0 to 3. All we care about is the entering. So this is e prime of t dt, right? We're good with that? Okay. How many people are inside the stadium at t equals 4? So I have to take into account how many people were already there, how many people came in, and how many people left. So that a of 4 then will be my initial amount, my a of 0, which is 412, plus the people that came in. So I'm integrating for that e prime of t dt. And people started entering at time equals 0, and we went all the way to 4 hours, right? Then subtract, and this is where you got to be careful, and this was the first one of these that have come up like this. People didn't start leaving. It wasn't on the same time interval, because the other one said on the same time interval or whatever. It said starting at time 2 p.m., that's when they began to exit. So I am subtracting the L prime of t dt, but I have to start at t equals 2 and go to t equals 4 for that. Okay, does that make sense to you there? We good? And then if I'm going to write an expression involving one or more integrals that gives the number of people in the stadium, this is going to be a of t equals 412 plus, I'm integrating from 0 to whatever t is, of e prime of what? X dx minus, then I'm going to integrate, where do I start? 2. Go to t, and then that's L prime of x dx. Okay. T was 1. Okay, so then that's when you kind of go to the left, you go back in time. It works. Yeah. We good with that? Okay. Okay. What other questions you got? Okay. All right, so then we are going to actually put these into our calculators. So what I would do, or what I did actually, is I labeled, I said, okay, I'm going to put this in F1 and I'm going to put this in F2. Like I wrote that down for myself so I didn't mess it up. So then we're going to go to our calculators. I'm going to add the calculator. Then I'm also going to add a graph. Okay, then we're going to type in an efficient manner, these two equations. So E prime, this means you have to turn on your calculator. Are you okay, Marco? You okay? Okay, you got to turn on your calculator. You got to push buttons. Okay, all right. So we have 536.5 e to the negative 0.1 x. Then I'm going to double check myself. And then we have to make sure we hit enter. That was a mistake for a couple of people, right? Enter. Then in F2, tab to get that. 398 sine pi. Pi is down here to the left of the H. Double check myself. Hit enter. I don't understand your question. Oh, I think I see what you said now. I see what you're saying. I didn't catch that. I think that's just a typo. Good catch, though. Yeah, this right here is what you're talking about. Yeah, good catch. That should be T. I think that was just a mistake. I hope. Otherwise, I have no idea. Otherwise, they're trying to confuse us, and I can't teach you this. That's just a mistake. That's a good catch, though. I didn't even notice that. All right, so that's what your weird graph looks like, which is kind of irrelevant, right? Okay, let's make sure we all have them typed in here. We good? No, we're not good. Well, maybe. Go up another one. Why does yours look different than mine? Oh, never mind. You are good. It just looks different on my graph. We're fine. Yours just isn't very dark in the middle. It looked like it was missing. So I was wondering. All right. So do we all have it typed in? We all have this weird looking thing? All right. So go back. And so now we're going to type in that first one. And it's E of t. So that's going to be your F1, right? What do we hit? Menu. Yeah. Menu. And we want to do what? Calculus. And we're going to do an integral. And we're going to go from 0 to 3. And then this is going to be F1. I'm going to hit variable F1 of x dx. Okay. So we get 1390 point, what was it, 510? Yeah, and you can't have half a person, so, to me, it's 1390, right? And we asked Miss Bruce about that. On her paper, it says 1391, and I don't know about that. So I don't know. I'm going to have to we're going to have to ask her about that again. To me, you can't have half a person. Although I guess if they're halfway in, then they've entered. I don't know. So we'll put the little question mark here, and we're going to double check with her on that. I'll double check with Ackerman on that too, so see what his opinion is. I really feel like if you put this and then you say that, that's going to be kind of, they're going to understand what you're saying. I don't think they're going to nitpick on things like that. All right, are we good on that one? All right, so you think you could type in the next one and get the answer? Why not, Devin? It's too long. I bet you can do it. I have faith in you. Oops. they're still a whole person. Wouldn't it be terrible to feel like you're only half a person if you're missing limbs? Oh, that just seems rude. You're terrible. Just stop it. Okay, I'm trying to get rid of the. Okay. Yeah, I don't need this bad karma. You don't need to stop. F1 of x dx minus we're going from 2 to 4. F2 x. Do you see the value in actually putting the equations in the graph and not having to retype the whole nonsense every time? No. Lie to me. 1472.529 equals 1472.529. Oh, I can't even write what I'm saying. 29. So that's 1472 people. All right. How do you feel about that? Pretty easy? Not so bad? We can do this? Okay. All right. So then I'm going to turn you loose. And I want you to, well, actually, we'll do the first part of this one together. You ready? This is a small car dealership in Lebanon, has 29 cars in a lot. At time t equals 0. You are not even listening to me. A of 0 equals 29. Okay, during the time interval, new cars are added. And so this is my rate in. During the same time interval, that's important, right? They're sold and removed. So this is rate out. So this first question is asks you a little bit differently. It says, is the amount of cars on the lot increasing or decreasing at time t equals 11? Explain your reasoning. So this isn't asking me how many, it's just asking, is the rate of cars on, or the amount of cars on the lot increasing or decreasing at t equals 11? So what do you think we need to find? Right, like substitute them in. So, okay, figure out what our rate in and what our rate out is at t equals 11. So we want n of 11, and we want s of 11. So we will go back to the calculator. We're going to go back to the graph, and we are going to put new equations in. So I'm going to back that out. So in F1, I'm going to put n of t. So type that in. And 3 x squared okay, and then you can always go back and double check your graph, double check your equations to make sure that they're correct. I think mine are right. And I think on here I'm also going to write down that this was F1 and this was F2. Bless you. So now I can find F1 of 11 and F2 of 11. And those are my two answers that I get. It's a good way to evaluate things. Let me know if you're not with me. Did you type them both into the graph? Okay, so then I went back to this screen and I evaluated F1 of 11 and F2 of 11. So I can get my two little answers. Okay. All right, so is the amount of cars on the lot increasing or decreasing at time t equal 11? What do you think? Is the amount of cars increasing or decreasing? Why? Exactly. This is our rate in, right? This is our rate out. So at t equals 11, the rate in is greater than the rate out. Therefore, it would make sense that the amount of cars is increasing. So we can say the amount of cars is increasing. Ugh, I guess I can't write. At t equals 11, is it hours? It says cars per day. Okay, so this would be t equals 11 days because n of 11 is greater than s of 11 cars per day. Do y'all agree with that? Does that make sense? Understand how we knew what to actually look for and whatnot? Okay, so now I really am going to turn you loose and you work through the rest of these. You got this.